Alrighty, today we are doing box plots and outliers. So just so you guys are aware, a box plot, also called a box and whisker plot, is a graph used to depict quantitative data by dividing the data into quartiles, which we learned about yesterday. And it helps us to see the spread between the quarters of the data pretty easily. An outlier, so extreme value, unusual or extreme value is what an outlier is. So there's actually a formula to determine whether something is extreme or unusual enough to be called an outlier. So there are two formulas actually. In order to see if there's a lower outlier, so an extremely low number, you do Q1 minus 1.5 IQR, and if you want to see if there is an upper outlier, you do Q3 plus 1.5 IQR, and if it's higher than that value, then it's an outlier, and if it's lower than that value, it's an outlier. So these are just formulas, but because they are formulas, you're going to need to memorize them. So I've written the steps on how to make a box plot right here. So to make the box plot, you need to arrange the numbers from least to greatest and then do the 5-number summary, okay? But before you're going to use those to make the box plot, you need to test it for outliers using the formulas up above. Then you're going to label your x-axis with the appropriate scale, mark vertical lines at each of the 5-number summary topics, and then make a rectangle and put stars where the outliers go. So we'll do that right now with this next set of data. So it says make a box plot of the data. So our step 1, and you could do this in your calculator if you want. Actually, let's do it in our calculator. So I told you guys yesterday that your calculator can put things in order from least to greatest. So I'm hitting stat. I'm going to go into L1, and I'm just going to type this list. Ignore what I have in L2 because we only have one data set, so we only need L1. So I'm just typing these in. You should type them in too to make sure that your brain actually has to think about pushing the right buttons and helping store it in your memory. But also, it's not really rocket science here. If you want to do something with the stats, then you should probably use the stat button. So this shows that my last value is the 16th value. I just want to count these real quick. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. And so then I can go hit stat again, and I can pick option number 2, which is sorting them ascending. So ascending means from least to greatest. And then I just have to tell the calculator what list I want it to use. So I'm going to hit the blue button. And then down here, if you look on the number 1, there's an L1 above it. So if I hit the blue button and then the number 1, the L1 should come up. And then I hit enter, and it says done. So now if I go back into my list by hitting stat edit, all those numbers have been put in order from least to greatest. So I'm just going to copy those down on here. Trying to get them both in there. So 40, 52, 62, 64, 70, 73, 74, 75, 78, 78, 3 78s, and then I have some 80s, and 4 80s, and then my last one is that 85. So there's the numbers in order from least to greatest. So after I do the least to greatest, I do the 5-number summary. So I'm going to go ahead and identify my min. for now is 40. We'll get into that in a second. Then I want Q1, but before I can find Q1, I should find the median. And then I need Q3, and then the max is also easy, it's 85. So who knows if 40 is extreme enough to be like a lower outlier. It's 12 away from the next number, but even that is further away from these other numbers, so that's why we have the formula. So before we can do that, we're going to go ahead and find the median. So it's going to be between the 8th and 9th number because there's 16. So again, if you're not quite sure, just keep going till you get to the middle number. So, sorry, I just messed that up now, didn't I? So it's in here between 75 and 78. So I'm just going to average those. A lot of you can do that in your head, but just in case you can't, you just add them together and divide by 2. So the median is 76.5. And then to find Q1, we're now going to do the same thing here. And so this is, let me do that again so I don't accidentally. So what's the middle of the way between 64 and 70? Again, if you can't do it in your head, just use your calculator. Divide by 2, and that's going to be 67. So Q1 is 67. And then same thing over here for Q3 is going to be right here. Because there's 4 numbers, then 4 numbers, then 4 numbers, then the 4 numbers. And you do include the min and max when you're finding these. So this is going to be 80. Alright, so step 2 up here says to find the 5-number summary. Step 3 is to test for outliers. So when we do outliers, I just make it real simple. Q1 minus 1.5 IQR. And Q3 is plus 1.5 IQR. Okay, so that means we need our IQR. So right here, IQR is going to be 80 minus that 67. So again, if you're like, oh, that's 13, I'm just double checking because, you know, my brain is kind of fried by the end of the day, and it's 8:15. Which is close to my bedtime. Maybe not yours, but okay. So then to see what the boundary is, we are going to take Q1, which is 67, and we're going to subtract 1.5 times that 13. And then this is going to give us like a boundary, and anything less than that boundary is considered an outlier. So 67 minus 1.5 times 13 gives me 47.5. So what that tells me is that this number right here, this 40, is an outlier. And the reason it's an outlier is because it's less than this number right here. 40 is a lower outlier. Right? So 52 isn't, because 52 is bigger. Okay? So let's finish up the next one. So if we do Q3, which is 80 plus 1.5 times 13, we get 99.5. So we don't have, 99.5 is the boundary. So if I go to my list, if there's any number bigger than 99.5, then it's considered an outlier. But since there isn't here, we would say no upper outliers. Okay? So because we do have a lower outlier, though, we're going to have to go and change our minimum, because this is an outlier. Okay? So 40 is an outlier. So 40 can't be our minimum on our box plot. So the next number, you don't have to recalculate anything. You just simply go to the next number, which is 52, and we're going to consider 52 to be our minimum. Now that's counterintuitive because you've done all this data and you're like, no, there's only 3 values to the left of Q1 when everything else says Q4. For whatever reason, statistician said, nope, don't do it, just leave it. So we're now here on label the x-axis with appropriate values. So you can't just label your 5-number summary. It doesn't work that way. What we're going to do is look at our minimum, which is 40, and our maximum, which is 85, and pick an appropriate scale. So to me, I'm probably going to count by 5s just so that I'm not, like 10's too small, but 5 seems to be fine. So 40, 45, 50, 55, 60, 65, 70, 75, 80, 85. Okay? And then 40, 45, 50, 55, 60, 65, 70, 75, 80, 85. Okay, so that was step 4, and looking up ahead it says mark vertical lines at each of the numbers in the 5-number summary. So what that means is I'm going to go to 52, which is my new minimum, and I'm going to just put a vertical line, and then I'm going to go to 67 and put the same height of a vertical line. Notice it's not right on the graph, it's above it. Then I'm going to go to my median, which is 76.5. Then I'm going to go to my Q3, which is 80, and then my max at 85. So that's step 5. Step 6 says make a triangle around Q1, median, and Q3. Does that say triangle? No, it says rectangle. I just said triangle. Make a rectangle. So I'm going to make a rectangle. So that's what it's supposed to go from Q1 to Q3. And then 7 says connect the minimum and Q1 with the horizontal line. That's what it looks like. Not at the top, it goes through the middle. And then do the same thing over here. So this is why it's called a box and whisker plot, but we just shorten it to boxplot. So this is the box part, and these are considered the whiskers. And then last but not least, we have to put a star at our outlier. So our outlier occurs at 40, so we put a star to mark the outlier. And you can have more than one outlier, but in this case we only have one. So what this tells us is that most of our data, 50% of our data, falls between the values of 67.5 and 80. The middle right here is at like 76.5-ish. Not ish, that's what it is. And because this graph is skewed because of the outlier, if anyone asked me what measure of center I would definitely use the median. I would not use the mean. Okay? So up here it tells you how to find the 5-number summary in your calculator, so I'll just revisit that. So we already have all of our data stored in L1. So now we're just going to hit stat again, scroll over to calc, enter on one variable stats, enter again so that it calculates it. Now your calculator is different than mine because mine's older, but notice the 5-number summary if you scroll down. Our minimum is 40, our Q1 is 67, our median is 76.5, 80, and 85. This doesn't give you outliers, so if this ends up becoming an outlier, then you need to go into your calculator, or sorry, go into your data and pick the next number. You can graph these on the calculator, but like they're really hard to work backwards to label your axis, so I don't recommend it. But if you just want an extra check, go into the stat plot, turn it on, and the box plot one that we're going to use, because you see 2 box plots here, is this one right here, because it's the one that takes into account outliers. So I would hit enter. Notice it just changes to XList, and then I'd hit graph. You don't really see it as well as you'd like, so if you hit zoom and then you go to 9, it'll zoom it based upon a stat graph instead of a regular graph, and that allows you to see it a little better, so you can see that it does have an outlier. Alrighty, so now you're like, well, how do I determine the scale? That's the hard part. If you're super techie with these calculators, then you know, a really easy way to do it is just change your window from, let's say, your minimum to your maximum, and then we scaled ours by 5, so I can scale that by 5 and hit graph. So that lets you kind of see better. You can also hit trace and it'll tell you what those values are right there. But again, that's memorizing which buttons do you have to push in the calculator, because trace doesn't seem super intuitive, but it's up to you how you do it. I'm going to keep kind of doing these without the calculator graphing part. I'm still going to use it for my list. So, okay, we're going to move on to the next question. Don't worry about that. But when we work with this question, we are actually going to change the question because I am not there with you to record the data, so I'm just going to change it. So we're not going to, this was that data we collected, how much you spend on your phone each day, and since I'm not there, again, we can't do that. So instead, what we're going to do is we're going to look at the data from a study in the Journal of Toxicology that studied infant motor development based upon the number of days that baby was exposed to cannabis during the first trimester of being in utero. So I'm going to give you those scores. It's kind of hard because you don't have them on your paper. So I'll write them right here. So if 0 days, if there were 0 days of cannabis exposure, then these are the motor development scores for the babies. So we're just going to do this. I'm going to cross that off. So we have 95, 100, 102, 104, 106, 106, 108, and 114. So that's for 0 days. So they had no exposure to cannabis during the first trimester of being in utero. Now, what if it was like 1 to 44 days? So either in trimesters, you're in utero for 9 months, divide that by 3, that's 3 months that you're being exposed. So this is like if you're being exposed from 1 day to 1.5 months. So the motor development for those kiddos was 90, 92, 93, 99, 99, 102, 105, and 108. How nice that they're already in order from least to greatest. Okay, and then finally we also have one for if they were exposed for over 1.5 months up to 3 whole months. So their motor development scores are what I'm writing down right here. So they must have given them some test, or I don't even know how they did it. You know, did they wait till they were born to test these things? We don't know because it's not in the data that they've given me, but who knows. So we can write this so we know. Cannabis exposure. Let's actually write days of cannabis exposure during first trimester and motor development scores, just so that you guys, if you're referring back to this, ever have that. Okay, so we have 3 different sets of data. So in order to make box plots of each of these, I am going to go into the calculator and hit Stat, Edit, and then I'm going to go and clear L1, I'm going to clear L2, and I'm going to clear L3, which it's already cleared. So those kids that didn't have any cannabis exposure, I'm entering into the calculator. So there's all theirs. There's 7 scores. 1, 2, 3, 4, 5, 6, 7, 8. I have 8. And then the next set, I'm putting in L2 so that I don't have to keep going back and forth between my input and actual calculations. And then my last one is going to go here. Like, you guys can already see that the numbers are lower, but not always. Like, look at this person, this baby. Okay, so then I hit stat, I scroll over to calc. I'm going to do one variable statistics, and default is L1. So when I type that in, you can hit second and then the number 1 for L1, but default is L1. So for that right there, if I'm doing the 0 days, and I'm going to try and color code this for you guys. The 5 number summary, we have minimum is what? 95. Q1 is 101. Median is 105. Q3 is 107. And the max is 114. So you're just going to want to quickly check these for outliers. So Q1 minus 1.5 times the IQR for this guy, which is 107 minus 101, so that's just 6. So when I do that math, I get, I'm not going to write Q1, I'm actually going to write the value. So I'm testing for outliers here. I don't really think there are going to be outliers because there's no really extreme values, but we always test. We defend our answer. So any number less than 92 would be an outlier, and we don't have any of those. And then here, if I do Q3 plus 1.5 times 6, so 107 plus 1.5 times 6 equals 116. So it would have to be greater than 116 to be an outlier, so there's no outliers. Alright, so that's the first set of data. Second set, here's the really cool thing. We already put it in list 2, so just stat, scroll over to calc, one variable of statistics, but this time we're going to hit the second and the number 2, and that makes this say L2 now. So it tells the calculator to go to the other list, and then we get our numbers from there. So our min is 90, Q1 is 92.5. This is not going to be color coded. I gotta go back. Miss Vulcan. Yours doesn't have to be color coded. Min is 90, Q1 is 92.5, median is 99, and Q3 is 103.5, and the max is 108. So if I do my IQR test on this guy right here, I have one, let's start with the upper one, so 92.9 minus 1.5 times the IQR, so 103.5 minus 92.9 is 77. So do I have any numbers less than 77? No. And then for the other one, it's going to be Q3, 103.5 plus 1.5 times the IQR, which says 119.4. Do I have any numbers bigger than 119? No, so there's no outliers for that data set. And then we have our last one. So stat, scroll over to calc, and this time we hit second and the number 3 to call up L3, and then we have our data, our 5 number summary. The min is 85, Q1 is 87, the median is 91, Q3 is 102, and the max is 104. And real quick again, I'm just going to test for the outliers. So it's going to be 87 minus 1.5 times the IQR of 102 minus 87. So that gives me 58.6, and since my lowest number is 85, that's not going to be it, but I think I just messed that up because my Q1 is 87, so I typed in a 1 instead of a 7. There. 64.5, my lowest number is 85, so I have no lower outliers. And then when I do the other one, plus 1.5 times 102 minus 87, my upper outlier is 124.5, and since my max is 104, I have no outliers. Sweet, no outliers. So what we can do now is make a make the box plot for these guys, but we're going to put them all on the same scale so we don't have to make 3 different box plots. So the smallest number by far is 85, and the biggest number is 114. So I'm probably going to go by 2s. I'll start with 84, 86, 88, 90, 92, 94, 96, 98, 100, 2, 4, 6, 8, 10, 12, 14. 86, 88, 90, 92, 94. This one is 104. Okay, so I'm going to color code mine. So I'm going to do this one right here. We have, remember these are going by 2s, so I have 95. And if you want to put your labels, because it's hard for you, then it makes it easier. 101, 105, 107, and then 114. So these are the 0 days of exposure. The next one is going to be 90. And then 93-ish. And then 99. Then 103, almost 104. And then 108. So this is the 1 to 44 days. So like this data is definitely more spread out from the range of it, but if you notice the middle 50% is more closer together than the middle 50% of this data, and this whole graph is shifted down, meaning their scores are lower because they're to the left. And then the last one we have 85 and 87 and 91 and 102 and 104. So those middle 3 lines get connected. Yeah, there's a lot of variation in the middle 50% of the data for those kiddos that are from 45 to 90 days. So, which group has the higher median score? So that's going to be the 0 days group. Which one has the largest range? So that's the biggest spread. So it's really close because of these two guys right here. So we can just do the math. The red group is 114 minus 95. Which is 19. The orange group is going to be 108 minus 90, which is 18. Ooh, that's really close. And then the last one is 104 minus 85, which equals 19. They're all pretty close, but which group has the larger range? It's actually the 0 days and the 44 or the 45 to 90 days. And then finally, which group has the larger IQR? We don't need to calculate the IQR. We can see from the graph that the 45 to 60 days has the largest IQR. Sorry, 45 to 90 days. Alrighty, let's flip it over. We have one last problem here. We're going to do this super fast because we're cool like that. It says, here's the fuel economy of several 2014 vehicles. So I'm going to put them into my calculator to get the 5-number summary because I think that's what's going to be fastest. 13, 15. So you already see that extreme value of 66, right? So let me just make sure that I have all my numbers, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 21. All right, stat, calc, one variable statistics, default is L1. So my 5-number summary is going to be minimum is 13, Q1 is 18, median is 23, Q3 is 28, and the max is 66. So you obviously are like, whoa, I should probably test for outliers, especially the upper outliers. You should always test for outliers when you're doing a box plot. It's a really easy way to miss a problem when you already know what you're doing. So I'm going to find my IQR, which is going to be 28 minus 18, which is 10. So that's good. And then I'm going to do Q1 minus 1.5 IQR. So, and then I'm going to do Q3 plus 1.5 IQR. And these are just our boundaries to the left and to the right of the minimum and the maximum. So this is going to be 18 minus 1.5 times 10, which 18 minus 1.5 times equals 3. So do I have any values less than 3? No. So no lower outliers. Okay, next one, I'm going to take Q3, which is 28, and add it to 1.5 times the IQR of 10, which equals 43. So then the question is, at 43, do I have any numbers bigger? Do I have any values greater than 43? Yes. 66. So 66 is an upper outlier. So then I want to take and then change my maximum to not be 66 and notate that that's going to be an outlier, and then change my new maximum to the next largest number, which is 32. So I'm going from 13 to 66, so I'm going to go by 5s, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65, and 70. Anywho, we can fill these in. Okay, and then I'm just going to graph Q1 is 13, or sorry, the minimum is 13, Q1 is 18, the median is 23, this is 28, Q3 is 28, and our new max is 32. So there is what most of our data is doing, and then I have an outlier all the way over here at